Okay, so going back to actually, I'll just say it. What would y'all like to look at? Like, what do y'all have anything that you want to ask about in particular? The chain, like the one step chain one. Okay. Okay. So that was yeah. I certainly can. This was the lengthiest one of them all. So let's look at this first block. We did some of the multiples of 3 before I left. So in this first block where you're doing functions with powers, um, which ones would you like to look at here? Or do you need to look at any of them? 12. Did we not do that in class? Okay. Okay. So number 12. Need to give y'all a title page. It's almost Friday. All right. So number 12. Okay, you could do this as a quotient rule. I would not. You're not going to avoid the chain rule. There's no way around the chain rule on this one. And since you're not going to avoid the chain rule, I would prefer to do only the chain rule by bringing that denominator up and raising it to what power? Negative 1/3. It's the cube root. The cube root is the same thing as a 1/3 power. You bring that up to the top, it becomes negative 1/3. And now we have a chain rule. So my derivative would be, bring down the negative 1/3 times negative 3 is 1, which you don't need to write, but I'm gonna. We leave the inside alone. X squared minus 4x. Subtract 1. Negative 1/3 minus 1 is negative 4/3. Then we will multiply by the derivative of the inside, 2x minus 4. You can leave it like that. There's no real benefit to changing it, but you could get rid of that negative exponent by taking, I want that line to be horizontal. That's better, I guess. You could take this piece as a negative exponent, move it back to the denominator. You don't need to do that, but there will be a time where doing that does make the next steps easier. Good on 12? Maybe. 14. Secant cubed. This is one that a lot of people fail to recognize as a chain rule. Now, if you failed to recognize any of these on this sheet as a chain rule, that's on you because the directions tell you to use a chain rule on all of them. For trig functions raised to a power like this, it's best for you to think of it, and if you need to physically write it this way, it's the same thing as secant x all cubed. So think of it that way. Now we have a clear inside that we will leave alone. We'll bring the 3 down. Leave the secant x alone. To the to the second power. So I bring the 3 down, I subtract, do not touch the inside. Now we will multiply by the derivative of secant, which is secant x tangent x. Secant squared is the derivative of tangent. And you're done. Now again, you could write that. We have secant squared times another secant. This is all multiplication. There's no addition anywhere. And so you could rewrite that as 3, and that is secant cubed x and a tangent x. No need to, just pointing out that it could be done. Good. Good. Let's see, what next? What next? What about do we have any more in this first block, numbers 1 through 15? Okay. What about the trig? 16? Did I hear 16? And you do need to know all those trig derivatives We will be using them literally for the rest of the year. The derivative of, first you need to recognize that x cubed is the inside function. We will ignore that. That's our gum. We'll leave that alone. And the derivative, we'll start with the cosine. Derivative of cosine is negative sine. Now I'm going to leave a little bit of space there. Leave x cubed alone. Then you multiply by the derivative of the inside, which is 3x squared. But I left that space because I prefer to put the inside derivative right. Too big. There. I prefer to write it that way. Now, if you want to put it on the right side, that's okay. And you're done. Cannot do anything else to that. Pearson mask. Hopefully. Well, what was the rule for the optional masks thing? 2 consecutive weeks of less than 1% positive. What was last week? Did we get 1 week in? Oh, it's not. I guess it would have to be district specific. Parents would be in an uproar if one school was. There'd be riots. Oh, I do remember that. Yeah, my daughter's over there. The entire team? What do they do? Are they like kissing each other over there? What's going on? Man. All right. Continuing with this. Whoa. All right. Any other questions on trigs? Okay. Shh. Let's do 22. I kind of like 22. Should I do 22 or 25? All of them? I can. They don't take that long. Okay. So, starting with 19, which y'all didn't ask, but since I have it, the derivative of secant. Remember, you ignore the inside. What's happening right there does not affect your first pass of the derivative, and the derivative of secant is secant tangent. So it's secant tangent. All right, and you leave the inside alone. You do not change the inside. It's 2x cubed, 2x cubed. Then you multiply by the derivative of what was inside, and the derivative of the inside is 6x squared, and that's it for 19. Good. Let's see. My head's too big. Kind of like throw that into the other screen. I'm in the way here. All right. Number 20. Oh, whoa, what's going on here? Number 20, the derivative of cosine is negative sine. You leave e to the x alone, then you multiply by the derivative of the inside. Now, I would prefer to write that as negative e to the x, sine e to the x. Good. Cotangent. Derivative of cotangent is negative cosecant squared. Negative cosecant squared. We leave the square root of x alone. Now, the derivative of square root of x is it's 1/2 x to the negative 1/2, which I'm going to write as 1 over 2 root x. Same thing. But if you write 1/2 x negative 1/2, that's fine. 22 was one I suggested because the inside's a little bit tricky because the derivative of, well, on the outside, the derivative of sine should not be difficult. That is cosine, and you just need to know that. We leave the inside alone, but now I have to do the derivative of 1 over x cubed. How do you do that? Yeah, bring that x up to the top. It's x to the negative 3, and then you would bring the negative 3 down, x to the negative 4, and you can leave it like that. If you want to make it negative 3 over x to the 4th, that's the same thing. We don't have to change it. Good. All right. 23, derivative of cosecant is negative cosecant cotangent, and you keep the inside the same. You do not change that inside. So it's negative cosecant of all of that stuff, x cubed plus 7 cotangent x cubed plus 7. And then the derivative of x cubed plus 7 is 3x squared. And now we're done with 23. Takes up a lot of space. How's life? Good out there? Good out there. All right. 24. Derivative of tangent is secant squared. We leave e to the x plus 2 alone. Then the derivative of e to the x plus 2 is e to the x, and you're done. How are we? 25 is almost identical to 22. The interior's got a square root, but it's in the denominator again, so it's going to be very similar. So the derivative of sine is cosine. Leave the inside alone. Then the derivative of that, this one's a little bit trickier. 1 over root x is the same thing as x to the negative 1/2, right? Then when I multiply by the derivative of that, we'll bring the negative 1/2 down. X to the negative 3/2. We good? And stop. That's it. (26). Now 26 is a little bit weird looking, but that is a chain rule. Everything on this sheet's a chain rule, because that sine x is taking the place of what is normally just an x inside a secant. And the derivative of secant is secant tangent. So it's secant tangent, and we just leave the inside alone, which was a sine x. Too many trig functions here. Secant sine x, tangent sine x. That took care of the secant part. Now we look at the inside, and the derivative of sine x is cosine x. That's a dumb looking one. And then 27. Derivative of cotangent is negative cosecant squared. Leave the inside the same. Although I think just to help me process the problem, I'm going to rewrite it like this. Now, I didn't really change the inside. It's still the same thing. I just changed the way it looked to make the derivative process easier for the chain rule. And then we'll bring the negative 1/3 down. What's negative 1/3 times 4? Negative 4/3. X to the... Oh, hang on. What's going on here? Oh, no, I don't want all that. There we go. I just need to give me some room here. All right. Negative 1/3 minus 1 is negative 4/3. I think I heard that a long time ago. And we're done with this. Good. Yes, ma'am. Did y'all like chant those together? Was she?
She didn't want us to work together.
She tried so hard to be an actual teacher.
Well, she needs to be.
But it's like she's being a sub. And like she doesn't know the flow of this classroom.
Yeah.
Did she contact you?
No.
Okay, she was fine. I contacted him and he said that he wanted y'all to work on classes.
She said that?
Yeah.
No. Are you kidding me? No.
She literally said, I contacted him last night and he said that he worked quietly and he just sit there by yourself.
Where is my stuff from? What was my first day gone? Friday?
Well, she was here. She was here Monday.
Miss Perry was here Friday, Monday.
And she was here Tuesday. She may not have seen. Hang on.
Miss Perry didn't like your sitting there. She
Because you weren't wearing your mask?
No, we're sitting on the desk. I was sitting on the desk.
Oh. Yeah, you're not supposed to sit on the desks. They don't like that. Have y'all seen all the desks that have like the broken bars on the side and the desks are kind of doing this? It's because they're not made to support human weight. They're made to support books and papers and stuff.
But she made her like
Ah. Usually I put in my general instructions. I guess I didn't. I just point out that calculus is generally a difficult class and to let them work together. But I don't know if I did that. She definitely did not call me though.
You said she contacted.
I never heard anything from any sub. Whatever. All right, let's go back and look at some more of these things. Okay. Okay. Going to, let me move my head back over here. Let's see, looking at this next block of problems, exponential functions should not be painful in here. We tend to have this mental hang-up when it comes to exponential functions, and I don't think they should be as bad as y'all generally, and I say y'all collectively, students generally make them out to be. For example, this first line of problems, they're all really nice. They do get a little bit more difficult when the base is not E, when the base is like 4 and 2 and 3 and 7. The good thing is that we very, very, very seldom run into non-E bases. It's almost always a base of E when we're doing these derivatives. So looking at these first three, which I don't think, did anybody even ask for the first three? I don't know. But the first three, the derivative of E, what if it were just an X? Forget the 3X. What if it were just E to the X? It would just be E to the X. So when I do the first part of the derivative, we just copy it down. All right, so that's the derivative of E. That takes care of the E part, but inside the E is a 3X. So now I need to multiply by the derivative of 3X, which is 3. I prefer to put the exponent's derivative first, 3e to the 3x. For 29, it's e to the x squared plus 1. So I know my derivative is going to have e to the x squared plus 1 in it. Now I just have to multiply by the derivative of x squared plus 1. 30, the exponent is x cubed. The derivative of that is 3x squared, e to the x. They're really nice. And generally, oh, thank you. Don't do that. Generally speaking, your rule for the derivative of e to any function is the derivative of the exponent times your entire original function. So that's your rule for exponential derivatives. That includes the chain rule. They're very nice. Very nice. Let's see. The next line. Have a couple that are not base E, so that brings another little wrinkle to it. But the first one's not bad. What's the derivative of square root of x? 1 over 2 root x. And then you just copy the original. 32, it starts off almost the same. We do the derivative of the exponent. Derivative of 3x squared is 6x. Copy the original, 4 to the 3x squared, just like I would if it were in E. The only difference here is that that is not base E, so you just need to multiply by the natural log of 4 and you're done. That's the only addition. And technically we are doing that with the E functions also. If I take all of these up here and I multiply by the natural log of the base, you're fine. That is true. That is correct as well. That is correct as well. What is the value of natural log e? If you punch that in a calculator, it's 1. So in the case of e, the natural log of e is 1. So all you're doing is writing times 1 at the end. So since it's times 1, it's not necessary for e to the power. Any other base, though, natural log of 4, I don't know what it is, but it's not 1. It's some weird decimal, so you have to include that. 33 is going to work out the exact same way as 32. Your derivative, the exponent's derivative is 2x times 2 to the x squared plus 1 times the natural log of the base. The exponential functions, I think, are some of the nicest ones. We just have to get over whatever happened to you in Algebra 2 and Pre-Cal. You've got to get over whatever they did to you to scare you. Good? Good. I mean, really quickly, I can give you the answers to the rest. The fourth root of x is the 1/4 power. So the exponent derivative is 1/4 x to the negative 3/4. 7 to the 4th root of x, natural log 7. That might be the hardest one. And again, we're not going to see very many at all. There are not going to be very many at all that are not base E. Children, Cedar. Wrong person. For some reason, Pearson. I don't know. Maybe because he's tall like your brother. Is your brother tall? Kinda. I don't know. He's taller than me, which is saying a lot. It takes a lot to be taller than I am. I'm a pretty big guy. All right. Do we have any questions on the exponential ones? Any other questions on the exponentials? Okay, the last block is going to be the most difficult one because you cannot lock into a single thought process. Everything on that previous block of problems was all exponential, so you can kind of lock into it. You want to do all of these? 45? 40? Maybe? Let's see. And my plan is to, at some point, maybe, I probably won't get it done today, maybe by the end of the day, Monday, is to go through all of the worksheets that I left and work those out and have the answers for you so you can check them online. I am going to take all this from you at the end of the day today. I'll try to get back to you Monday. But if you want to go back and check some of the other ones, I'll try to have the answers up. And on the front table up there, I put these up there, I think it was either last Wednesday or Thursday. They were delivered right before I left. But the publisher of the textbook finally sent me the solutions manuals for the books. And I put 2 copies of it on the front table up there. Those have answers to every single problem in the book, evens and odds. And so anything that we do in the textbook, you can check the answers to the odds in the back, but the evens are in that. You're more than welcome to go grab those books and look at them during class, or if you want to check something, that's fine. They also have a little bit of an explanation. It's not only answers. It does include a few steps that might help you for the textbook problems. And so those are there for you. So I'm not going to post any answers to textbook stuff because there are hard copies of them up there. I will try to post answers to all the other stuff, though. Let's see. So number 40. First, we want to identify the inside, and the inside function is this. So we ignore that part first. And I start by differentiating stuff to the 5th power, and the derivative of stuff to the 5th power would be 5 times the stuff, which I don't change, to the 4th power. Then we multiply by the derivative of that interior. Derivative of 2x is 2. The derivative of 2 to the x is 2 to the x times the natural log of 2. And if you want to kill it dead, you could also multiply by 1 because 1 is the derivative of the exponent. That would be like really taking the chain rule to extreme levels. It's not necessary, though. And there's your answer for 40. Yeah? 41. 41, y prime. This one, what kind of derivative are we looking at here? Obviously a chain rule, but it's the exponential, which means the derivative would be what? Okay. There, that sounded better. Okay, and when you say the function, I assume you mean the exponent. Okay, so there's the interior, so you ignore that. The derivative of e to the power is e to the power. And then we multiply that by the derivative of the exponent, which is 1 over 2 square root of x. Now, if you want to write it as 1/2 x and negative 1/2, you can, but I'm telling you, it's going to be beneficial for you to just remember that the derivative of root x is 1 over 2 root x. There will come a time where that's very helpful for you. 42? What's the answer to 42? You should, in a perfect world, almost be able to do that immediately in your head. Cosine of, and you're done. Good. You don't have to put the 3x squared before the cosine. I just think it looks better that way. Also, some of y'all are not very good about your parentheses, and you'll write cosine of x cubed minus 7 times, whoops, that's not a 7. 7 times 3x squared. And if you write it like that, I really can't tell where the cosine function ends. Now, if you put parentheses here and parentheses here, then it's very clear what's happening. But I prefer to put the inside derivative before the trig function. Yeah. 43, 44, and 45. I think I heard somebody ask for 45 earlier. Did I? Okay. So what's happening with the... Whoa. Come back. Please, down here. Okay, so 43. What do you think? Yep, 4 to the cosine x times the derivative of the exponent, which is negative sine x, times the natural log of 4. And you definitely need parentheses there around the negative sine x, because without the parentheses around the negative sine x, it's going to look like 4 to the cosine x minus sine x. The parentheses make it clear that we're multiplying. 44, what do you want to do? Bring that bottom up. Make it e to the x minus 4 to the negative 5. And now we have a nice chain rule. Y prime, negative 5, e to the x minus 4 to the negative 6 times the derivative of the inside, which is e to the x. How are we doing on these? Good. You people in the back, are y'all all okay? Okay, let's take 45. Give me some room down here. Y prime is? Okay, there's where I would start. The inside is that stuff, and the derivative of the square root of stuff is 1 over 2 square root of stuff. And I cut you off as soon as you said that. What was the rest of it? And then what? Yep, the derivative of the interior is negative cosecant x cotan x. That takes up a lot of space. I don't know how long I'm going to keep writing the derivatives of square root of x like that, where there's a chain rule. I prefer to stick the inside derivative in the numerator. It's the exact same thing. Whoops. It's the exact same thing as what I originally had written. This just kind of condenses it a little bit so that it's all a little bit cleaner looking. Well, I am having a really hard time writing today. There we go. Good on those three. Let's see. 46 is nice. I don't know if I'm going to do 46. Should I? That'll be secant x tangent x times e to the secant x. The exponent derivative times the original. Cotangent cubed. Bring the 3 down. That's the quantity of cotangent x cubed. So it's going to be 3 cotangent x squared times negative cosecant squared x. We good on that one? I'm going a little bit quickly here. 48, the outside is tangent x, the inside is 5x. Or I'm sorry, yeah, the outside is tangent, inside is 5x. Derivative of tangent is secant squared. So secant squared of 5x times 5 times the derivative of the inside. 49 will be cosine x times e to the 2 plus tangent sine x. 50. Ooh, should I do 50 in detail? I don't know. There's a 4 on top instead of a 1. It seems like all of the other ones where I had a number on top, the number was 1. So for 50, start by bringing that bottom stuff up. Earlier, somebody, when we had 1 over, somebody said flip it, which with 1, that's kind of okay. But instead of saying flip, let's say bring the bottom up, because I'm scared if you say flip it, you may accidentally move the 4 to the denominator. You're not actually flipping the fraction. You're just bringing that bottom up and giving it a negative exponent. And now when I chain rule that one, negative 3 times 4 is negative 12. Leave the inside alone. Then the derivative of sine x plus e to the x is positive cosine x plus e to the x. Derivative of sine is positive cosine. And I would just leave it there. Get on 50. 51 would be negative 5 times e to the negative 5x. 52 would be 5 to the e to the x times e to the x, which is the derivative of the exponent, times the natural log of 5. We okay there? Good, bad, ugly. 53, 47 times all that stuff to the 46. And then in parentheses, you have to put all this in parentheses, 21x squared minus 8. If you do not put 21x squared minus 8 in parentheses, you're wrong. You have to put that in parentheses. And 54, I'm going to have to write this one too. This one's kind of ugly. I'm going to rewrite 54. The only radical that I don't rewrite is the square root. The square root function, I just know the derivative of square root of x is 1 over 2 root x. Everything else, it helps if I rewrite it. So we'll have x squared minus the cotangent of x to the 4/5 power. And then after that, hopefully it's not too bad. The derivative is 4/5 x squared minus cotan x to the negative 1/5 times the inside derivative, 2x. What's the derivative of cotangent x? It is negative cosecant squared. If I subtract the negative cosecant squared, that will be plus cosecant squared x, and I'm done. How do we feel? We getting the chain rule okay? All right. What else? What do we have? We got up 45 or 50? We got up 50. So we have about 13 minutes. 13 minutes. Anything out of the textbook? There were some problems that were dealing with graphs, I think, and stuff. Yes. I need to wait. Okay, Paxton, which one? Oh, this one. Let's see if the graph showed up. Sometimes this thing, when I print the pages from the book, it doesn't show all the graphs. Yeah, that looks like it's showing them 57. This one? Cool. All right. Okay, I'm not going to grab all of the directions and stuff. We need the table. And, whoops. We need A and B. Okay, I like these questions. I think we may have done a whopping one of these before I left. Is that about right? Yeah. But I really, really, really like these because you don't have as much. You don't have as much computation and arithmetic and stuff to deal with. Why are you writing? Said I had the pointer. There we go. Oh, geez. All right. So they want you to find h prime of 1, and they gave you h prime of x. The first thing I want to do is find out, or they gave you h, not h prime. First thing I want to do is find out what is h prime of x. And when you're adding things like this, you do them completely independently. So I'm going to start with 2x. What is the derivative of 2x? 2. Then I move on, plus the derivative of g, which would be g prime of x. Since we don't know what g is, the best we can do is just symbolically say its derivative is g prime. And then it asks for h prime of 1, which means now that I have a formula for h prime, I need to plug 1 into all the x's. 2 is just 2. Don't have to worry about that. What is g prime of 1? It is 1. And we're just going up here to the table. Here's g prime. Here's 1. And they intersect at a value of 1. So g prime of 1 is 1. So we get 2 plus 1, which is 3. We good? What am I going to do with b? I need q prime, just like here I needed h prime. How do I do this derivative? That's a quotient rule. We have to do the quotient rule on this one. And so the quotient rule starts with f of x times g prime, so that's low d high, minus high d low, all over low, and then we plug in 1. Q prime of 1. Why did they put 4 in here? None of the problems had anything to do with 4, did they? Was there a C or something? Were there more questions? Whatever. All right, so f of 1, g prime of 1, minus g of 1, f prime of 1, over f of 1 squared. And if you want to skip what I just wrote and go straight to substituting their values, I'm okay with that. I'm just doing this in painful detail. F of 1 is, we're looking up here, and we're only looking at this top row. We're looking right there. So when x is 1, f is negative 3. G prime is 1. G of 1 is negative 8. F prime of 1 is 5. All over f of 1, which is negative 3, squared. And then we just do the arithmetic. Negative 3 plus 40 over 9 is 37 over 9. How do we feel about those? I like those questions. I like them. They also reinforce just like your general understanding of what the rule itself is by writing it like this. Are we good out there? Any others? Okay, so that would be, I don't know when the second set was. Not there. Not there. The review one? Okay. 65. Okay. Ooh, oh, never mind. Shoot, I was getting excited. I thought I saw a second derivative in here. So do you mean the very last, like part D, or do you want all of these? Okay. I'm fine with whatever. Just want to make sure I knew what you were asking. They're the exact same type that we were just doing. Exact same thing we were just doing. Instead of giving you the values as a table, they wrote them this way. So for number A, how do you find the derivative of a sum like this? Yeah, you just treat them like separate problems. S prime of x would be f prime of x plus g prime of x. Technically, there's not really a sum rule for derivatives. You just treat them separately and you add them together. I guess that would be the sum rule. And then we plug in 1. S prime of 1 would be F prime of 1, which is 3, plus G prime of 1, which is 1, and 3 plus 1 is 4. Good? B, we have a product. Oh, how clever. These little stinkers, they're giving you too many hints. Do you see what I'm talking about? I guess not. All right. So P prime is F prime times G plus F times G prime. All right, so that is your product rule. And then P prime of 2, not X, would be F prime of 2. So I'm going to go up here. I'm going to go ahead and put the values in. If you want to write F prime of 2, G prime of 2 plus F of 2, G prime of 2, that's fine. I'm going to skip writing that and go straight to their values. F prime of 2 is 2. G of 2 is 1. Plus F of 2 is 1. G prime of 2 is 4. That's 2 plus 4 is 6. Good? Bad? Ooh, bad green. That's a little better. All right. What about Q of X? I'm going to need Q prime, which would be just your very definition of the quotient rule. Low, D high, minus high, D low, all over low, low. And then we're going to evaluate this at 1. Q prime of 1. And we're looking at the ones here. G of 1 is 3. F prime of 1 is 3. Did I do the first? Did I get that one right? Did y'all get 6? Okay. I think I got it right. Okay. Minus, okay, now I just lost. You should never stop in the middle of a problem. I just lost my train of thought. G of 1 is 3. F prime of 1 is also 3. Okay, I got that right. F of 1 is 2. G prime of 1 is 1. So that's going to be 2 times 1 all over G of 1, which is 3 squared. 9 minus 2 is 7 over 9. Are we good? And then D is C of X. How do I do the derivative of that? What kind of derivative are we looking at? That is a chain. It is not a product. Mm-hmm. Yeah. Sum, product, quotient, chain. SPQC. Yeah. They shouldn't have done that. Made it too easy for you. Calculus is easy enough already. They don't need to give you hints. All right. So I need C prime of X, which means we have to do the chain rule, which means you start on the outside, leave the inside G alone, then the derivative of the inside. And here is one that people very frequently mess up on the evaluation. With product, quotient, and a sum or a difference, the F's and G's are completely separated. Like even if they're multiplied by each other, we still complete the F prime of X before we start the G of X. This one, the G of X is inside the F prime. So when you start evaluating this one, you really need to do this in different steps. I'm plugging in 2 for my X's. And I would start by evaluating only the G of 2. I would do that part only. G of 2, where is it? Is 1. So we have F prime of 1. And you could go ahead, whoops, that should be a 2. You could go ahead and evaluate the G prime of 2 if you want to. I'm going to leave it like this, though. Now I have F prime of 1, which I can find up here is 3. And G prime of 2 is 4. And we get a final answer of 12. How are we feeling? Okay. Any other questions, comments, concerns? 47, same page? Okay. 47. Oh, F double prime, son of a stinker. Okay. F prime on 47 should not be painfully. Oh, I got to go fast. Okay, I'm going to go fast. F prime of 47 is a chain. It'll be 1 over 2 square root of the inside times the derivative of the inside. And I'm going to clean that up. 2 will divide into 4 to reduce that to a 2. Because I have to do something with this derivative, I'm now going to bring the bottom up. Make it to the negative 1/2. Now my next derivative. Hey, on your way out, drop your stuff in the basket for those of you who are heading out. So I'll bring the negative 1/2 down. Negative 1/2 times 2 is negative 1. 4t plus 1 to the negative 3/2 times 4. Then I'll plug 2 into that. So F double prime of 2, negative 1. 4 times 2 plus 1 is 9. Negative 3/2 to the 4th. What? No, I don't care. Negative 4 over 9 to the 3/2, which is negative 4 over 27. See ya. There. So I got it done in a crazy, loud ending. And cut.